Myself, Srinivasan. I'm working as a professor in Mechanical Engineering Department at Sri Shanmugha College of Engineering and Technology. I'll be talking about activation function. This is most important topic in neural network system, and because that activation function is going to be a deciding factor whether the neuron is going to fire or not in neural network. Basically, what is happening if you look at a neuron in a hidden layer, it gets the input from the input layer, all will get summed over there, and then it will be activated by a mathematical function. So if you don't have any if you don't have any activation function, that neural network is going to be just like a linear model. Okay. So because of the activation function and because of the activation function, the neural network will learn the curves, boundaries, and other features in the sample. And there are two categories of activation function. I can say one is linear one, another one is non-linear. If you look at a linear one, and the output is going to be the output is going to be from minus infinity to infinity. Okay, then output is proportional to the input. The derivative is going to be constant when you have a gradient, when you go for a gradient, and it is going to be constant. And this can be used for the regression problem. Okay, so when we come to nonlinear one, and first we are going to look at the step function. The output is going to be 0 and 1. Then the z value is less than 0. Then again that output is going to be 0. The z value is greater than or equal to 0. Then we can say the output is going to be 1. Since it is a step function, it is not going to be a differential one. It can be used for the classification problem. Okay. Then in the another category, I mean in another nonlinear category, we are going to look at sigmoid and tanh functions. Then sigmoid function, the output is going to be from 0 to 1. So whatever the z value, if you give minus negative to positive values, you could be able to see from 0 to 1. Okay, when the activation function is less than 0.5, that it is going to be class A, and if the activation function is greater than or equal to 0.5, it is going to be class B. Okay, so it is going to be useful for the binary classification. Since it is a smooth function, we can able to differentiate. Okay, and similarly, if you look at nonlinear one, and this is going to be a hyperbolic function, and the input values ranges from -5 to 5. You could be able to see the negative values and positive values in the activation function. So that's why I can say the output is going to be 0 cent. Okay, and there is a way. I mean, both sigmoid and tanh function will undergo gradient issues in the neural network system. Particularly, I can say vanishing gradient and exploding gradient problems. Okay, and what is vanishing gradient problem? As long as in backpropagation we try to update the weights, and gradients are going to be very small, and when the gradients are very good, it's going to be very small, and then the neural network system will not be able to learn anything, and will not be able to learn anything. So when you have a high gradient, what is happening? It grows exponentially, and it will lead to instability. Okay, so that is the disadvantage of sigmoid function and tanh function in neural network system. Okay, either it will go to vanishing gradient or exploiting gradient problem. Okay, so that is the reason we don't mostly we don't work on this. And the tanh can be used because since it is a zero-centered, I can use for the case of time series problems. So that's why it is used in RNN. Okay. In order to solve the issues in sigmoid and tanh, that is vanishing gradient and exploding gradient, we can use the ReLU function. In ReLU function, what are the input that we give, and what are the input that we give, that is even if it is a negative value, that output is going to range from 0 to positivity, 0 to infinity. If z is less than 0, that is negative value, it is going to be 0. If that z is greater than or equal to 0, then it is going to be z. Okay. So when you differentiate, we can be able to differentiate. If we differentiate, it is going to be 0. So we don't learn. We don't get we don't get the gradient is going to be 0 in the negative values. Okay. In case of what will happen in ReLU is that as long as you have more negative values, it will end up with dying ReLU. Okay, it won't learn anything. Okay, so in order to avoid that, we can have some constant. For example, here in leaky ReLU, we will fix that 0.01 is a constant, and in case of parametric ReLU, it is that alpha is going to be a learnable one. Okay, so over a period of, over the training period, it will learn from the network and automatically it will adjust. Okay, that is the advantage of parametric ReLU. Okay, so when you go for the gradient, when you take a derivative, then it is going to be alpha. Okay, so that's why the most preferable one is parametric ReLU, because that alpha is going to be a learnable one. Okay, so that's why it is mostly used in CNN and deep neural network systems. Okay. So sigmoid and tanh both will work for the binary classifications. If you want to go for the multi-class problem, for example, animal. If you look at animal will have different categories like dog, cat, and so on. And if you want to predict what is this and what is cat, what is the percentage of cat and what is the percentage of dog, we can work on softmax functions. Okay, so based on the output layer, if you apply a softmax function, based on it will give you the probability. So that is the advantage of softmax function in neural network system. So based on the discussion that we had so far, we can say these are the ideal characteristics one should have. Okay, ideal characteristics of activation function one should have. It should be a non-linear one, because most of the problems are real-world problems are non-linear, and it should be a differentiable one. So that's why if you are able to differentiate, and we can able to update the weights in the backpropagation neural network systems, and it should be computationally efficient, and it should be zero-centered. If you have a zero-centered one, most of the weights are going to be gradients are going to be nearer to 0, then it converges very fast. That's why it can be used in RNN. And in order to avoid the vanishing gradient problem, we can use ReLU functions, and ReLU also will have some dying issues. And to replace that, we can use parametric ReLU that will learn over a period of time. So I can say really among all, ReLU is a non-saturating activation function. Okay. So far we have seen what are the different activation function used in neural network system.